Yeah, this video is dedicated to Miss Kiesler. We're going to show you the finer points of mathematics. Incorporate some into your studies. So, all right, here we go. So I'm going to do this the long way. We're going to say 9 times 6 times x times x. And you would never have to do this. I won't make you do this, but I want you to see where this comes from so we understand. You can pull factors apart to see what cancels. But I want you to be very careful when you start canceling stuff. You have to ask yourself, why is it that I cancel? Well, in this situation, if you looked right away at the beginning, you'd say, well, I'm going to cancel an x, and I'll cancel a factor of 6. Well, why does it cancel? Because 6 divided by 6 is simply 1. And anything multiplied by 1 gives you itself. So you end up with 9 fourths times 1 times 1 times x, which is just 9x over 4. So that's why it works. That's why we can cancel. It doesn't make 0. It doesn't, it makes 1. And in multiplying, you multiply by 1, you get itself. You can also have terms that are binomials that cancel as long as it's written by factors and multiplications. Then we reduce 8x squared over 4, get 2x squared. But if you get too careless, all of a sudden you see letter C and you just start crossing off x's, right? And get your fingers cut off. So don't do that. What can you do for letter C? Take out the factor. What are you going to take out? Very good. Now it's written as multiplication, so you can go ahead and do your cancellation. 5 over 10x makes 1 over 2x. If you're not careful, what would you do to letter D? Cross off the x squareds. Again, and we don't cut fingers off in this class, we cut heads off. So, it's not like you got 9 lives or something like that. One-shot deal. So, and just for good measure, make sure we all understand what mistake would somebody make that would be entirely inappropriate here. Cut off the x's, okay? So make sure that you're making sense of your properties and doing the appropriate step. Okay, it says multiply the following rational expressions. When you multiply, really nothing changes. But you might, peek ahead a little bit and kind of see if something might reduce. So for example, 4x and 2x reduces to 2 over 1. And 3 over 9 reduces to 1 over 3, so we get 2/3. And just like in example B, what's going to cancel out? The x plus 2's, and then you can see that the 4 over 12 reduces to 1 over 3, so we get x minus 1 over 3. Pretty straightforward. As you noticed yesterday, we practiced factoring. Today, we actually put the factoring to use. Try letter C and D on your own. Okay, for letter C, you should get 3 over x minus 5, and for letter D, you should get x minus 1 over x plus 1. Any questions on that? Okay, so what do we do if we divide? Yeah, multiplied by the reciprocal. We don't like to take 6 divided by 1/3. That's confusing to us. So we multiply. We say that's 6 times 3. And so the answer is 18. So that's how we think of fractions. And so we're going to do the same thing in this situation. We don't flip the first one, just the second one. Multiply by the reciprocal. And now you can go ahead and do your fancy-dancy algebra. 4 or 1 times 1 over 3x, 4 over 3x. Sometimes you like to save space, so instead of rewriting the entire expression, maybe you just flip the second part and then cross that out and write as multiplication. Maybe that's the way you do it. Whatever works for you, we're all about conserving paper. A is 4 over 3x. B, this is not correct. Now I have to cancel x minus 2. I have to cancel x plus 1. And I'll write the answer as x times x plus 2. If you wanted to distribute it, that would be fine, but I would leave it in factored form. Now, does anybody know what actually the common mistake in that situation is? Forget about flipping it. Anybody almost make it in this hour? Anybody know why somebody might write x plus 2 over x as opposed to x times x plus 2? They see the x in the denominator, so they may think, okay, it still belongs there. But even more likely, they get used to writing fractions all the time. If you notice our previous examples here, we had a fraction, 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 and their mind just says fraction. I made that mistake. I bet in the 6 years I've taught this, I bet I've done that probably twice where I've written the wrong thing on the board. And, I just get used to writing the fraction. I stop thinking about what I'm doing. So be careful and pay attention. Okay. We try C. How does x squared minus 1 factor? Yeah. And then I'll flip this here. How does x squared minus 9 factor? Yeah. So it's a very nice difference of 2 squares. And you can see that the x plus 1s, those cancel. And the x plus 3s, those cancel. And again, both terms are in the numerator, so you'll leave it as x plus 1 times x minus 3. Yes, Braden? Oh, whoops, sorry. Thank you. There we go. You try D on your own. I get x over 3, or x plus 3 over 3 times x plus 4. All good? Okay. Move on to the last example, example 4, A, B, C, and D. And now we want to talk about adding and subtracting. So we've done simplifying, done multiply, divide, now we're going to add and subtract. And tomorrow we look at complex fractions. Something like, say, 1 over x squared minus 4 plus 2 over x minus 2 all over 1 over x plus 1 over x plus 2. Something like that. Okay. Wow. It's like, I guess I struck a nerve. So let's keep it easy for right now. If I'm going to add fractions, I have to have common denominator, so I multiply top and bottom by 2. Oh, thank you. It's my third mistake of the day. They're all coming during this hour. The day must be getting to me. All right. So we got 14x minus 11 over 6. How about B? Can the denominators have expressions as opposed to numbers? Yeah, they can. And so you would just write this as 2x minus 3 all over x plus 4. No need to change anything so the denominators are the same. However, when you get to example C, now what? Now, what is the tempting thing to do in this situation, though? Yeah. So this is actually something that I will see from time to time. You know, and it looks like a nice, quick little shortcut, doesn't it? But it's entirely incorrect. You can't do that. It's very illegal. And how I keep myself from making that mistake is when I see x minus 1, I think of a number 6. So say x is 7 and x minus 1 was 6. I would have to multiply top and bottom here by 6 and top and bottom here by 7. So I'm going to do the same thing in this situation. Multiply top and bottom by x minus 1, top and bottom by x. And I get 2x squared plus 3x minus 3 for x times x minus 1. Now, I would not distribute the x through in the denominator. I can see further into the years of mathematics that you'll have ahead of you, and trust me, you're better off to leave it in factored form. Now, if this factors, then you could try to factor it and see if something cancels. But that does not, in fact, work in this situation. Okay. And how about the last example, D? Should I multiply the top by x squared minus 4? Why? Okay, so if you have a denominator that factors, it might be worth it to actually factor it. And then you can see the term that you need to add so that they have a common denominator. And so what are you going to multiply by? Just simply x minus 2. So that makes it, you know, easier. You would still get the right answer, but you would have to do some more simplifying. So we have 5 minus 6x plus 12 divided by x plus 2, x minus 2. So that gives me 17 minus 6x over x plus 2 times x minus 2. Very good? Nice quick review for the day. Your assignment is not very long. Your assignment yesterday was a little bit longer, so. Now, so it looks like there's only about 11 problems total. About 6 from there, 3 from there, 2 from there. So, you know, we did, what, 16 problems in class right now, I think. So. Maybe. Yes, exactly. We're gonna have a throwdown over star qualities. So, two more things to keep in mind before you go today. Number one, you guys know my good friend Morgan Jellinger? Is that how you say her last name? Jellinger? Whatever. Okay, all right. So Morgan had a birthday on August 14th, and she decided to celebrate it today. And so we had birthday treats today in third hour. No, but I'm just reminding you that if you do have a birthday at some point you want to celebrate it, bring treats on it. Second of all, I encourage you to wear cherry red, navy blue, and white tomorrow. Show your Tiger pride. I think the last day of the week, we should all wear our school colors. And it's game day for somebody, so yeah, go. Support Ella. Yeah. And Zach. And Justine. Tiger pride.